Hello, Vanakkam, welcome, Namaskar, Marhaba, Sat Shri Akal, Hola, Bonjour. This is Shreyas Sir and you're watching the Zero to Superhero course, the series for all the JEE and NEET aspirants for your NEET and JEE preparation with me, Shreyas, your physics master teacher. And like every time, these are basically revision series with concepts, with problems, with PYQs, with mind maps, and also all the tips and tricks which are required to solve the questions. Today's session, like you can see, well, it's all about collisions, center of mass, and work power energy. Very much related chapters. You need a lot of energy considerations even during collisions, especially in inelastic collisions and stuff like that. So we'll also be seeing the center of mass, formulas and other stuff related to it in today's session with me, Shreyas. Those of you who do not know me, well, my name is Shreyas. I'm the physics master teacher. I've been training for a very long time, and many of my kids have done really well when I have mentored them. And I'm very proud to say this, that they are in the top 2-digit All India ranks, and there are thousands of kids whose lives I have touched, and I'm very proud about this fact. So I did my engineering from NIT Nagpur, did my research from IIT Bombay, and I have been in the coaching industry for more than 10 years. So I know what it takes to do in the last few days, in the last few weeks, just before the run up to the examination. You want to know more about me? You can go to Instagram. That's my Instagram handle. You can definitely get in touch with me as well. So I hope you have hit the like and the subscribe button, and also join the Telegram channel link, which is there in the description box below. I can just show it to you right away, right now. It's somewhere here. So while you're watching this, okay. And hello, Joyce, Hema, Nikita, Shrikant, Hariprasad, A. Nagraj, Umesh, Satya, Nadela. Wow. Kondeti, is this useful for JEE Mains? Yes, bacha, it is. Hi, Sanjay. Hi, Shrikant. Hi, Ankit. Hello, Inilya, Lakshmi. Hi, Jaya. Hello, everyone. So you will see in the description box only, all the links are mentioned. So you can see right over here, you will see Instagram link, Telegram channel link. Just click on this. It will open up the Telegram account. Just make sure you join the group for the PDF updates, everything. Also, do not forget to hit the like button and also hit the subscribe button. I'm logged in through the admin account, so maybe it is not seen. Okay, and all the courses, be it crash, be it other stuff, it's all mentioned in the description box. So go ahead and check it out. So let's begin with the class. Yeah, it is a one-shot kind of a revision. Yes, it is. Hi, Doctor has been official. Hi, Saja, good evening. That I have made from your session, and I'll be regular. Okay, I understand, Ankit. I guess you have your maths exam. That's why you're saying so. But I want you to be very regular after that. I know you can give some excuses, but try to still be in touch with the JEE portion as well. Hi, Krish. Hi, Mithun Sri, MBBS. Okay, fine. I guess your question is answered. Okay, so let's begin with the class. Get ready, guys. We'll start with the mind map as usual. Okay, so the concepts that you need to learn in these 3 chapters, starting with work, is work done by a force, their sign convention, and also how to calculate work if the force is constant, and also what if the force is variable. And then comes the next part, which is work kinetic energy theorem, which relates the total work done and the change in the energy, kinetic energy of the system. Now, from that, you also get 2 kinds of forces. One is conservative, one is non-conservative forces. You should know which ones are conservative and what's their property, and the non-conservative examples, and what difficulty they cause in different kinds of situations. So that's the bifurcation of forces based on their work. And then we go to energy, the 2 main things, which is kinetic energy and potential energy, and when is their mechanical energy conserved, under what situation, and also the concept of power. So these are the main concepts in this chapter. Quantity Pasaro, it's all there in the playlist, bacha. If you're watching the video, you can check out the playlist is right there. Okay, so while you're watching this video right now, just go to the playlist out here and you will see the 0 to last minute revision series. So you can see 0 to superhero physics. Just click on this. You will be able to see all the classes out here. Okay, fair enough. Cool. Okay, I'll make sure that the list gets updated as well. Okay. Good evening, Sunaina. Good evening. Hi, Latish. Hi, Down. Good evening, Prince. Now, then you go to center of mass, where you find the center of mass using certain standard formulas, and two major, properties out there when you combine the two objects and when you remove some object from another object. Then also the standard formulas for all the symmetric bodies, and then you should go to the motion of center of mass, especially velocity, acceleration, and force. Then you go to collisions, and where you first talk about momentum, change in momentum, impulse, which is change in momentum, then the force calculations, average force especially. Then you go to conserving the momentum, and then you divide the types of collisions into three parts: elastic, inelastic, and perfectly inelastic. And there is a parameter which decides what kind of collision it is, which is called as the restitution coefficient. And then you also move on to 2D collisions or oblique collisions, like they say. Okay, so let's begin with all the concept revision and formulas, and if required, if you need some additional understanding, I'll be doing some solved examples as well. Are you guys ready? Hi, Yogesh. Quantity in the last days of JEE and NEET, you need one shots only. You cannot sit and study the detailed classes. The time for that is now over. Okay, the time for that was there back in January, maybe even till I would say March. After March, April, the time is hardly there because your boards came off and other stuff. So let's start first with work and all its sign conventions. So work, let's talk about everything that we can talk about work. So remember this, if I have an object or a system, and let's say there is a force acting on it, and let us say that this object moves, because of which the force also moves. So this is the displacement. So earlier this was the force. So as the object moves, you will see even the force moves along with it. The force also moves along with it, and there is an angle theta between that. So the work done, by that force, is the force in the direction of displacement multiplied by the displacement of the force. That's very important, displacement of that force itself. So mathematically speaking, it is F vector dot S vector, which is also Fs cos of theta. This is what work is. Obviously this is expressed in joules, and 1 joule is nothing but 10 to the power 7 ergs. This is SI unit. This is your CGS unit, right? Now a work can be positive, negative, or even zero. We'll talk about that as well. But before we go ahead, let me focus on this point, which is called as the displacement of the force. Now just imagine that you have some object like this. Just imagine, and you are applying a force over here. You're applying a force at this particular point. Now what happens? This object moves, maybe rotates or something like that, and because of which, after some time, this object reorients itself and becomes like this. That point P still remains there. This force is still acting at that point. This force is still acting at that point. If you notice, that object has definitely moved. Maybe the center of mass has definitely displaced over here. Do you think there will be work done in this scenario? The answer is no. Reason, the force has not moved. Only when the force which is being applied moves, that displacement should be taken into account. Is that clear? Everybody with me on this? Okay, cool. Similarly, you can also talk about that example in a rotational motion, especially of a rolling wheel. So this wheel is basically rolling. So when you roll, V is equal to omega R. Basically, there is no slip at the point of contact. So let's say there is friction. Let's say there is some kind of a friction over here. let's say Fs. So does this friction do work in rolling? Answer it in the chat box. Hema, this will be approximately for 1.5 to 2 hours. Is this friction going to do work? And if it is it positive or negative, or is it 0? Hi Jamesburg. Come on, put it up in the chat box. Definitely Rihan. For that, you need to first clear JEE Mains and JEE Advanced with a very good percentile and rank. Then you get into good branch, and then you start working with projects and then pursue your field. Negative friction? No. The answer is 0. Reason is when this moves, this sphere rolls, realize that this point is no longer going to be in contact. A new point comes. Maybe this point will now come over here. It will be a new friction. It's like, the surface touches, there is friction acting, that surface does not move, the point of contact does not move, and then it's taken out, a new point comes, new friction. That point again loses contact, new point makes contact, new friction. Every time it's a new friction which does not move, there is no slipping, hence there is no displacement, and if there is no displacement, there is no work. Is that clear? Is that clear? I hope this is clear. In electrostatics I have not covered because there is a separate chapter crazy called as Gauss's law. So there is a separate chapter in Pathfinder called as Gauss law. So in Gauss law chapter you will see the applications of that. Okay, so it's different. Rihan, my blessings are always with you, bacha. Okay, so let's talk about the convention now. There are 3 signs of work. The work done can be positive. So when it is positive, that means theta is acute. Theta is acute. Work is done. Work is done by the force. By the force. Work is done by the force. That is the meaning of positive. Then you also have negative. Negative, that means theta is obtuse. So in this case, work is done on the thing which is applying the force, or I would say by the system. By the system. In this case, it was by the force on the system. There is a clear-cut difference over there. And the last thing, if it is 0, then obviously no work done. This is possible if force is 0 or displacement is 0 or theta is basically 90 degrees, basically perpendicular. So these are the only 3 conditions under which the work done can be 0. Is that clear? I hope this is understood. Hello Rose, hello, welcome bachalo. Now moving ahead, now that we have spoken about work and all these things, this formula is mainly applicable when the force is constant. You can see it's F dot S. F is a constant force, but if the force is variable, then you need to use a slightly different formula. If F is variable, if F is variable, then what you need to do, you cannot just multiply force with displacement. You cannot just take the dot product. The work done will be integral of F vector dot the displacement vector. Sometimes the force can be in X, Y, Z component. So in those cases, remember, you will have to expand this because displacement vector will be dx I cap plus dy j cap plus dz k cap. So this is how sometimes it can look like. Oh my god. Okay, so just try to maybe put it over here. Yeah, dz k cap. Okay, so this is how it looks like. So this is also nothing but, if you draw the graph of force versus displacement, and I see that the force varies like this, then the area under that graph because integration is always related to area. So that area under the graph gives you the work done. If it is on the top, it is positive. If it is below, it is negative. And 0 means either the force will be not there or displacement will be not there, or they are perpendicular. Okay. Hi Nisha. Yes, Potipaka. You are little bit late, but little bit. Don't worry, you can catch up. I'm pretty sure you are understanding it as well. Yes, quantity, if the object is at rest also, you can see the work done will be 0. Fair enough, guys? Okay. Now, let us see if you guys can answer this question. Let me put it up over here. Imagine that there is a block which is kept at rest on an inclined plane, and this whole thing is kept in one box which is slowly taken up. It is moved with some uniform, let's say, velocity. It's moved with some uniform velocity upwards. Everybody fine till this point? Let's say this is some angle, let's say this is some mass, everything is given. You guys let me know in the chat box, for this object, what kind of forces will act? Put it up in the chat box. What are all the different forces that will act on this box? Put it up in the chat box. This is a very important problem. It will clear many of your concepts out there. Think carefully. Thank you, Rose, so much, means a lot. Okay, so guys, friction, gravitation, that's all. Mg cos theta is just one component. There are many forces. One is obviously mg. Yes, there will be normal. Do not forget that. What about pseudo force? Will pseudo force be there? Think about it. Will pseudo force be there? It's moving with uniform velocity. Uniform velocity means zero acceleration. No acceleration means inertial. Inertial means no pseudo force. Non-inertial will have pseudo force. Okay. Friction will also be there because it is at rest. Hence, the friction will prevent its displacement. Okay. Now, you only tell me which of these works will be positive, which of the work will be negative. Work done by friction, work done by mg, etc. You guys tell me which of these works will be positive, which of them will be negative. Think about it. Will normal be positive? Will normal be doing positive work or negative work or no work? Will friction be doing positive work or negative work? Will mg be doing positive work or negative work? Think carefully and put it up in the chat box. Pseudo force quantity is a fictitious force. It's a non-existent force which is just put on paper to make Newton's laws valid, because Newton's laws fail when you are in a lift-like frame which is accelerating. So that is called as a fictitious, fake pseudo force, and it is always going to be opposite to the frame's acceleration. Okay, so mg is going to do positive. Well, a lot of you guys are wrong because this is going up. Do not forget that the displacement is over here. This is your displacement vector. Normal makes acute angle. Normal makes acute angle, so it will definitely do positive work. Even friction makes acute angle, hence that will also do positive work. But if you notice mg is opposite to the displacement. Cos 180 is negative, so this will do negative work. Everybody clear about this? Understood? Oh, this will do positive because it's making acute angle. Check the acute angles and normal and displacement, friction and displacement. So a lot of people have this notion, friction, oh, evil guy, villain, negative work. No, friction can do positive or negative work. A lot of people also have the notion, oh, normal, perpendicular, sir. Perpendicular means zero work. Wrong. You can see it can also do positive work. It can even do negative work. In fact, all forces can do all kinds of work. So there is no restriction, oh, you can only do positive, oh, you can do only negative. There is nothing like that. Now, what if I tell you, I want to add all of them and I want to know what is the total work. Now, the total work, will it be positive? Will it be negative? Will it be zero? Or you cannot say. Let's see how many of you get the correct answer. Will it be positive? Will it be negative? Will it be zero? Or it is basically none of these, meaning it could be either positive, negative or zero depending on the values. Depending on the values. Come on, figure this out and let me know in the chat box. Quickly. Those of you who are even watching it recorded, you should definitely not look at the answer, you should think in this time. So JEE second registration, yes, started, Sneha. So yep, I think I have asked the team to post a notification about it in the community as well as our channel, so that everybody is aware of it. Well, hi Shiva, positive? Okay, so I'll tell you what, the correct answer for this, guess what? The correct answer for this is going to be 0. I'm like, sir, what? 0? I thought there are two positives, 2 plus 1 minus, or what are you saying? The answer is 0 because of the next theorem that you're going to study. And that is basically work kinetic energy theorem. And that says that the total work done is final kinetic energy minus initial kinetic energy. It is moving with uniform velocity. Uniform velocity means V is constant. If V is constant, that means final kinetic energy and initial kinetic energy are same. So shouldn't this be 0? Shouldn't final and initial kinetic energy be equal, because half mv square will remain half mv square, hence it is 0. So I don't even have to calculate it. I know the answer is just going to be 0. Yeah, it does not depend on the value. Beautiful question. I am pretty sure this has cleared multiple misconceptions from your head. So let's move to that theorem, and that is work kinetic energy theorem. Now before that, I think I need to talk about kinetic energy as well. So kinetic energy, so usually the symbol for that is K, which is nothing but the energy possessed by a body due to motion. Due to what motion? Not loose motion. It is due to normal motion. And the formula for K is nothing but half mv square. You can also write it as p square by 2m. This will also work. Momentum square by 2m. Obviously the unit is going to be joules or ergs only, nonetheless. And last thing that I would like to mention over here, that this depends on the frame of reference. Depends on the frame of reference. Frame of reference, as in the point of observation, perspective, where is the observer, all of that. So frame of reference. The best example of that, imagine you're carrying a suitcase and you're sitting in a bus. The bus is going. For you guys, does the suitcase have any kinetic energy? You just put it under your seat, it's just lying there. For an observer inside the bus, what is the kinetic energy? Come on, put it up in the chat box. Come on guys, figure it out. Hello Nitesh. Come on, think. Oh, no problem, Apple NEET aspirant. Wow, what nice names, funky names you guys come up with. Okay, so for an observer inside the bus, yes, it has 0 kinetic energy. Very good Pavitra, very good Nikita. Hi Kishore, hi Sindita. So yes, it has 0 because it is not moving, it's a relative thing. But for a person, let's say there is a Pandu or Champa standing on the ground. They're saying bye bye to you. So Pandu, Champa saying bye bye. For those kids out there, you will see the box is moving, the suitcase is moving, so it has half mv square. So it's a relative thing, keep this in mind. Okay, now let's talk about the work kinetic energy theorem. What does it say? It says the net work by all the forces, all as in literally all, internal and external, basically changes the net kinetic energy of the system. So usually it is put like this: net work is equal to final kinetic energy minus initial kinetic energy. This is how it is usually put. Keep this in mind. Okay, very important. This includes internal, external, everything. Not many people realize that even internal forces work done is included in this. Many people just think, oh, it's only external. No, it's not correct. Very good, Kusum, very good. Hello, Mokshaganga. All right, every day, Surya, my class timings are 7 o'clock, standard. Now, there are two kinds of forces based on the work and what they actually do. And those two forces are basically How many of you know this? There are two kinds of forces. One is those kind of forces which do work based only on their initial and their final location, not on the path. And if you bring it back to the same point, the total work done is zero. Total work done is zero. So those forces are basically called as conservative forces. Conservative force. So the meaning of conservative force is that, imagine that you have a force which is being applied, and let us say that there is a path across which you have moved that force, you have displaced the body, and this is nothing but a closed path. And you find that the integration of f vector dot ds vector comes out to be 0 for that closed path. Why have I put that circle? Why have I put that circle? It says it is integration, but for a closed path. That means you have returned back to the same point. This is basically called as a conservative force. And you will see that there is another interesting property of a conservative force, and that is nothing but if you go from this point to this point via this path, or if you go from that point, okay, to that another point via some another path, it doesn't really matter. The work done is the same. This will be also W and this will be also W, as long as the initial and the final paths are the final points are the same. So work done is independent of the path taken. The best examples of conservative forces, the best example of conservative forces can be gravity, electrostatic force, spring force. These are basically conservative forces. So mg, then your k, q1, q2 divided by r square, then kx, which is your spring force. These are basically examples of conservative forces. So what is the use of knowing this? The use of knowing this is that, imagine you are solving a pendulum question. Imagine you are solving a pendulum question, and the pendulum's bob comes over here, and for some reason you have to apply work kinetic energy theorem. Just imagine. Now that bob will actually travel like this, and during its journey mg will always be acting down. Mg will always be acting down, and during its journey the displacement and the gravity will keep making different angles with the displacement. Displacement and force will make different angles. So if I had to calculate the work done by gravity, it will be a crazy process, tedious process, because theta is changing. But I know mg is a conservative force, and conservative force, the work done is independent of the path. Now this path seems very tedious for calculation. So how about this? What if I go from here to here and then go from here to here? Now that becomes very easy, because in this path I know that the gravity is always going to act perpendicular to the displacement, so it will do zero work. It will do zero work from here to here. Makes sense? And from here to here, the gravitational force is in the direction of the displacement, so it will be nothing but mg into this whatever, this displacement h. That's all. So it becomes very easy for calculation. So I've replaced the curved path with a convenient path, that path which I find it more suitable for calculation. I hope this is clear. Thank you Mokshaganga for all the love, bacha. Yes, it does not depend on the type of path, Kusum. Yes, that's right. Under Lee studies, I want to start investing. What is your opinion? Kunditi? You can, bacha. Who am I to stop? If you think you can do well, definitely do well. I don't want to be that teacher who becomes an example when you become successful one day and then you are like, you're giving an interview. I always wanted to be an investor, but my teacher, he told you should study and you should get into IIT. But then I proved the teacher wrong. Now I'm a very good investor. Fine, if you think you can be a good investor, go ahead with it, bacha. But if you think you're just getting carried away, please don't take the risk. Go follow the path and then learn about investing, finance through your friends in college, and learn what is there in finance and then start investing. And that's what I would say. Okay, cool guys. Okay, the other type of thing is obviously non-conservative force, bacha. Okay, and let's see that part as well. So the non-conservative, that will not follow all these properties, non-conservative forces, these kind of forces, the example I will give you, so you cannot use these things like friction, viscous force, normal, tension. These forces are non-conservative, they are evil forces, they are bad forces. Keep this in mind. Okay, cool guys, let's move on. Fair enough. So we have completed many things in our mind map, like you can see, work kinetic energy theorem, work done by variable force, non-conservative forces, etc. Let's also talk about power, and then we'll go to energy conservation and mechanical energy as well. Okay, so I think here only I can add things about power because we have space. You'll be like, sir, why are you acting like this, sir? Please, there is so much of space. Guys, I just feel like putting a lot of things in one place. That's all. Okay, so power is basically rate of doing work. Rate of doing work. It is going to have a formula dw by dt, which is also F vector dot V vector. And the unit of power is watt, which is joules per second. Sometimes you can also use horsepower, and 1 horsepower is 746 watts. Roughly, in those times, they used to measure everything in terms of horses. So that's the average of your, a rough average horse. That's the amount of power that it can give. Crazy. At 746 watts. Hello, Sonalika. Good evening, bacha log. Is there any video for complete NLM? Yes, Naveen. I just did one shot yesterday. You can watch my yesterday's class. And detailed classes are obviously there in the 11th standard nurture playlist on this channel as well. Nitesh, if you got 229 in JEE mock test, will you get top 10 ranks? No, bacha. And you're studying in class. Acha, oh, you are in 10th. Oh my god, Nitesh, I am so sorry. You are in 10th. As my coaching institute completed. My god, Nitesh, hats off, bacha. Definitely you can come in top 10, but you need to maintain the consistency and do not get saturated and do not get overconfident or lose focus. Then definitely you can come in top 10. Naveen, if some concept is not clear, then go to that specific topic from the nurture playlist. And obviously you have the crash course. The crash course will have all the major things with assignments so that you can improve your skills on those specific topics. Now let's talk about energy, mechanical energy and potential energy. So starting with potential energy. Certain important things which you should know about potential energy. Number one, this potential energy, symbol U, unit joules again, and this U has no meaning usually. What has meaning is always delta U. Delta U, which is change. The change in the potential energy is what you usually need, not the absolute value most of the times, because something energy will be getting converted into some other form of energy. So you need to calculate the changes in the potential energy. So delta U is always minus the work done by the conservative force, which will give you minus F dot ds. You can also rewrite this as F is equal to minus du by dx, or du by dy, or du by dz, depending on which direction it is moving. So these are all interconvertible forms. Now this minus sign is very important, and this conservative is also very important, because potential energy is only associated with conservative forces. Like you can have potential energy for gravitation, you can have potential energy for electricity, you can have potential energy in magnetism, you can have potential energy of a spring. What is common in all these things is that if you go back to the previous slide, mg, spring force, electrostatic magnetic force, these are all conservative forces. You will never hear the word frictional potential energy, normal potential energy, tension potential energy, viscous potential energy, never with non-conservative forces. It's always associated with conservative forces. Keep this in mind. I hope this is clear. Next thing, this negative sign just tells you that just imagine, let's say I take a mass and I move it up. You guys quickly tell me, will the potential energy be positive? Will the change in the potential energy be positive or negative? Put it up quickly in the chat box. Yes, Apple NEET aspirant, you'll get the PDF in the Telegram channel. Yeah, I will be doing mock tests after next week. This week I'll be doing all the major chapters. Next week onwards, only mock test. Yes, it will be positive, very good, and it will be nothing but plus mgh. Now, if I ask you, what about the work done by gravity? The work done by mg, remember mg is opposite to the displacement, so it will do negative work. It will be mg into h. Don't you see, this and this are same in magnitude but always opposite in sign? Hence that minus sign comes. And it is not just true for this scenario, it always works, be it electric, be it magnetic, be it spring. So that's why that minus sign is there. You can see the minus sign continues over here as well. Keep this in mind. Okay, so certain formulas which you should know obviously in potential energy. First, let's talk about gravitational potential energy. So delta U for gravity is nothing but mg. How much is your change in height? Difference in the potential energy for a spring will be equal to nothing but half kx square. And you will study in other chapters like capacitors or inductors in 12th standard. There are also potential energy formulas in different forms. For inductor it is half Li square, for capacitor it is half CV square, and so on and so forth. You will study that in 12th standard, and if you are already in 12th, you know that already. Not just this, this formula is only applicable if gravity is roughly constant. If gravity is not constant, then make sure that you use the potential energy formula for gravity, which comes out to be U is equal to minus G m1 m2 divided by R when the gravity is not constant. Okay, when gravity is not constant, keep this in mind. Okay, having said this, there is one last thing which I need to tell you, and that is, since I told you it's never the U value which you are interested in, most of the times it is the change in the potential energy, or you always talk about potential energy with respect to something. Like you always assume this is the reference line. Acha, the block is here, the potential energy is mgh. Oh, the spring is not compressed, so no energy. You extend it. Oh, now half kx square. It's always with respect to something. So what is very important while you calculate the potential energy is you define the reference zero potential energy. That's that location or that situation which will have no potential energy, zero energy. You can assume it to be anything. It is basically your choice. It is your choice. Keep this in mind. Okay, something which you should know. All right, clear? Everybody understood this? Okay, so like for a spring mass system, it's usually the relaxed state. Okay, so that's how you go with it. Now, having talked about it, let's also talk about mechanical energy and its conservation. So what is mechanical energy? Mechanical energy is nothing but mechanical energy, E I can put MECH over here, is nothing but the sum of kinetic plus the potential energy. So if this is the case, the change in the mechanical energy is change in kinetic plus change in potential energy. Now comes the conservation part. Observe this. If the total work done by non-conservative forces, which are the non-conservative forces, in case you forgot it, these forces, normal, tension, friction, viscous, etc. If you see, these evil forces are not doing work. So basically zero work is done by the evil forces. Then delta E mech is basically zero. Basically, therefore, initial kinetic plus initial potential is equal to final kinetic plus final potential. This principle is called as mechanical energy conservation principle. Very, very important. And what if the net work done by friction like forces is, let's say, not zero? No problem. Then just make your own story, or you can just think of it this way: delta E mech, whatever is the change in the mechanical energy, will come or would have gone into the work done by those non-conservative forces. Those non-conservative forces will suck away the mechanical energy. It is not conserved. So here mechanical energy is not conserved. Keep this in mind. Is that clear, guys? Understood? Very, very important. So if there is air resistance, mechanical energy is not conserved. Friction, it sucks away the energy, mechanical energy is not conserved. If you think about this example, well, there is a pendulum and there is a bob, okay? This is a mass, this is length L, and this is going like this. There is tension, there is mg. You guys quickly tell me, in this situation, no air resistance, nothing like that, will mechanical energy be conserved? It's just a pendulum thread, it's going like this, maybe in a vertical circle or just oscillating. So do you think mechanical energy is conserved? Because all the conditions should be met, only then it will be conserved. Think about it. Come on, my warriors, think and quickly tell me, is mechanical energy conserved? This is mass, pendulum, length L, tension is there, mg is there, this pendulum is just going like that in a vertical circle. Is mechanical energy conserved? Yes. Umesh says yes, Joyce says no. Well, the condition is non-conservative forces should not do work. Is there any non-conservative force? Oh yes, there is. This is one force which is non-conservative. So this is non-conservative. But the best part is it is perpendicular to the displacement, because of which the work done by it will be zero, and if the work done is zero, hence mechanical energy will be conserved. So what does this example prove and tell you? It tells that sometimes you will see there are evil forces, but they are dormant. They don't do anything. They just stay quiet because they will not do work, and in those situations you can still conserve mechanical energy. Understood? They are dormant, they are not doing anything, hence you can conserve it. Some of the examples of this mechanical energy conservation and all of that, especially in vertical circular motion, which you should know. So vertical circular motion. So imagine this: if you have a track like this, okay, or you have to take a pendulum. This is where you have hinged it. This is the mass, this is the length. This is a car of certain mass. Fair enough. This is nothing but your radius. Here also the radius is r. I can call the length as r, no problems. This mass will go like this. Okay. For these situations, you will see that if it has to just complete the circular motion, then the velocity at the topmost point, how much should it be? Come on, put it up in the chat box. Think about it carefully. At the topmost point, I think we did it in circular motion. This velocity should be root gr to just complete the motion. Same thing over here as well. And at the bottom point, you should have little bit more velocity. That velocity will be root of 5gr. Keep this in mind. This is true if this is like a string. So this is a string, or it's a car going in a circular track. So this is basically a string. But you have this case where you have a rod over here. This is the rod, this is the point mass, this is the length of the rod, and you want this mass to go in a vertical circular path. In that situation, for it to just reach on the top and complete the circular motion, remember, a rod can never become slack. It's a rod, it can hold the compression, unlike a string which will just bend and it will just become slack. So in this case, the velocity should be more than 0. Anything more than 0 will work, and in that situation, the bottommost point gets a velocity, minimum velocity of root 4gr. Very, very crucial. Is that clear? I hope this is understood. Last point over here. Okay, the tension keeps changing, or if the normal keeps changing, keep that in mind. Here in this case, you will see at the topmost point the tension just becomes 0. Here at the bottommost point, oh sorry, this was not tension, this was normal, my bad. The topmost point, you will see that here the normal just becomes 0, here the tension becomes 0. Here this rod will be under compression at the topmost point. It will come under compression because it is going with so slow speed, and the weight will compress that rod. It's going so slow, it's not getting pulled, it's going to be under compression. Keep this in mind. Very important. Okay, let's move ahead. Let's talk about center of mass, formulas, and the standard results. Let's see how many of you remember all the results. So starting with center of mass, how to find it. So first important formula is, if you have number of particles, m1, m2, m3. So this is m1, m2, m3, mn, and each of them have different coordinates, different positions. So the location of their center of mass, I'll just call it as RCM, vector wise, will be nothing but m1 r1 plus m2 r2. So all the terms will come divided by m1 plus m2, and so on and so forth. You can also find out the velocity and other stuff. Maybe these particles are moving. So if these particles are moving, so I'll just mention it over here. If, oh my god, just one second. If the particles move around, okay, then you will get the velocity and so on and so forth. So you will get the velocity of center of mass will be nothing but m1 v1 plus m2 v2 upon m1 plus m2, so on and so forth. And acceleration of the center of mass, same formula, will be m1 a1 plus m2 a2, the whole thing upon m1 plus m2, so on and so forth. Now this formula works if you have distinct particles, but the moment you have a continuous body, so this is like a continuous body, in that case you cannot use this formula. The formula that you will use for finding the center of mass is via integration. So R center of mass will be integral R dm divided by the total mass. So this is how it comes for continuous bodies. And using this, you can find the center of mass of all the standard objects like cone, spheres, hemispheres, etc. Okay. Now, there are two kinds of problems that you usually get in center of mass, where you need to add things and where you need to subtract things. Example, I'll tell you. Imagine you have been given one object over here. Okay, just one second. Let's say like this. Okay, so this is an object whose center of mass needs to be found. What you need to do to find its center of mass is basically divide it into two parts. Basically divide it into two parts. Let me just draw it properly, guys. Okay, divide it into two parts. So that is basically called as addition. So this is the same as a square plus a semicircle. That's it. That's all. So to find the center of mass of this thing, you need to know the center of mass of this guy and that guy. Let's say I know the center of mass of this guy is here, the center of mass of this guy is somewhere here. Then all you need to do is to find the center of mass. You find the center of mass of this collective body. So RCOM will be nothing but, let's say this mass is M1, this guy's mass is M2. So M1 R1 plus M2 R2 upon M1 plus M2. M1 and M2 are their respective masses, R1, R2 are their respective locations. Okay. Now, and it all depends on the coordinate axis as well. Here I have not shown the coordinate axis, so it could change. So, oops, one sec. So let's say this is our coordinate axis. So make sure you maintain the coordinate axis. Like the coordinate axis should be as before. So make sure everything is with respect to the same coordinate axis. Don't make that mistake of using different coordinate axis. It should be consistent. This is one way. And there are certain situations where let's say for example you have something like this. Okay, some cavity is there, some hole is there, something is scooped out, something is taken out, and you want to know where is the center of mass of this guy. So in those situations, what you need to do, you should think which combination will give you this, or what should be taken out from what to give you that remaining diagram. So it will look something like this. You take this object, and from this you take away this thing. You will get this. So it's not plus anymore, it is minus. And let's say I know this guy's mass is M1, this guy's mass is M2. So the position vector of the center of mass in this situation will be nothing but M1 R1 minus M2 R2 upon M1 minus M2. This is the formula which I want to use. I hope this is clear. Harinivas, I don't understand what you're saying, Bacha. Please, Santosh, you have missed a lot of it. Okay. Sir, for the string at the sides, IT aspirant, so if the string starts from below and it has to just go till here, then the bottommost point, the speed should be root 2gh. So root 2gh becomes 0 and it comes back. So if it does not have to complete the circle. Okay, Bacha? Malvika, I think you also have missed a lot, but it's okay. Continue. Watch the live class. You can watch the recorded part. You can watch the remaining part in the recorded form. No problem. Okay. So, Hari, if your message was, when am I going to start 11th? I'm going to do 11th standard questions and revision series very soon. But meanwhile, there is a playlist which is there on our channel, Nurture playlist. Make sure you check that out. So, watch the complete Nurture series. I will not be doing a new Nurture series because it's a waste of time. Instead, I can use that time to do more problems, to give you more methods and help you with the problem solving skills. So watch those classes. Those are detailed classes of all the chapters. Okay, now standard geometries and there's center of mass. So center of mass of standard geometries. Let us see one by one. Let's see how many of you know this. Starting with let's say a solid hemisphere. Okay, this is solid hemisphere, and then I will also talk about hollow hemisphere. So this one right now is basically solid. This is hollow, that means it is empty. Same thing for a cone, right? This is a cone. Let's see how many of you remember the formula for a solid cone and then for a hollow cone. Solid cone and then hollow cone. Come on, guys. What will be the normal reaction dynamic beats? Where would be the normal reaction? I didn't get you in which question. And then you also have the formula for a sector and an arc. So very important. So this is like a piece of pizza like this, and this is just the arc. That means only the crust of the pizza is there. Okay, this is theta, this is r. Theta is there, r is there. This thing is theta. Height of the cone is known. So let's see how many of you remember it. So first of all, starting with the solid hemisphere. So for a solid hemisphere and for a hollow hemisphere, here are the formulas. For solid, it is nothing but 3r by 8. So this is where the center of mass is, from the base, not from the top. This is the distance which I have told over here. Here, in the case of hollow, the distance comes out to be just r by 2. Okay, this is r by 2, this is 3r by 8. If you get confused, think about it this way. Hollow, the center of mass will be on the top. In solid, there is more mass below, so the center of mass will be slightly lower. So 3 by 8 is smaller than half. So that's why this is small. 3 by 8, half is slightly more than 3 by 8. So it's going on the top. Same thing for a solid, the center of mass should be lower. For hollow, the center of mass is not as low as compared to the solid. So hence, in this case, this distance just comes out to be as h by 4, and this distance in case of hollow comes out to be as h by 3. Very much standard. Next, for a sector, this distance, this is where the center of mass is, comes out to be r, and then you have 2 by 3, you have sine of theta by 2, the whole thing divided by theta by 2. For just an arc, the center of mass is here, only the 2 by 3 does not come, rest all things will come. So this distance is given by r sine theta by 2, the whole thing divided by theta by 2. That's what it is. Now you might be wondering, why do I need these formulas? You will need it for, semicircle or quarter of a circle and stuff like that. Imagine, guys, I tell you, I want to know where is the center of mass of a semicircular arc. This is just an arc. Just imagine. I want to know where the center of mass is. What I'm going to do? Well, I know the center of mass will be somewhere here. I just need to know this distance. So I'm just going to use this formula. It's an arc. So the formula will be r sine theta. What is theta in this case? Theta is this entire angle, 180, which is nothing but pi radians. Always put pi in radians, not in degrees. So this will become r sine pi by 2 by pi by 2. Sine 90 is 1. 2 goes on the top, so it will become 2r divided by pi. So that's how you're going to use this formula for finding center of mass of any angle, arc or sector. This is a generic formula. Many people remember separately for arc, for for semicircle, for quarter circle, then you make it solid, then you make it hollow. It's crazy. This is why it is very easy. You can see it's very similar. Only that factor of 2 by 3 comes when it is a complete sector as compared to an arc formula. Is that clear, guys? Very much standard. Okay, let's move on to the next thing, that is momentum. and then we are going to come to some questions as well. So let's talk about momentum and impulse. So momentum and impulse. So we all know momentum is nothing but mass into velocity. Unit is kg meter per second. Now sometimes the momentum will change, and that change in momentum is just called as impulse. So J, which is nothing but your impulse is nothing but delta P, which is nothing but final minus initial momentum. And we also know change in momentum is force into time. So sometimes this is also written down as force into the time. So J is also force into time. This is if the force is constant, but sometimes the force may not be constant, and in those cases you will just put integral force with respect to time. So this is when the force is a variable. Example would be this graph. Okay, just let me put it up over here. This is a graph of force with respect to time, and like you can see over here, maybe that graph goes like this. So this area is basically this value of the integration. The area under force time gives you impulse, and the area under force displacement gives you work. Keep this in mind. Force time, impulse. Force displacement, work. Two different things. Okay. Is that cool? Everybody clear with this? Standard concepts which you should definitely know. Okay. Now that we have spoken about this, let's move ahead and also talk about conservation principle. Conservation. When is this momentum conserved? Conservation of momentum. Conservation of momentum. Whenever you see things collide, explode, etc., always remember, draw the diagram before and after. Always. What happens before and what happens afterwards. If you do not draw this, you are making the biggest blunder. You will not understand the things correctly. So in the before diagram, maybe, I don't know, this is going like this is there, these objects are going like that, I don't know. Afterwards, maybe these objects are going, I don't know, maybe like this. This is before and after. And if you take this system and you see that the net external force right from before and afterwards, let's say, comes out to be 0. There can be internal forces. I am not saying there are no internal forces. There could be internal forces. Doesn't really matter. Even before or even afterwards. These are internal forces. Internal forces may be not 0. Maybe, I don't know. Doesn't matter. If external force is 0, then you will see that the total momentum of such a system will remain constant at all instant. Constant for all the time instants, before, after, every time during the collision. So you can just say that the total momentum initially or before is equal to the total momentum, afterwards. But what about the energy, guys? Momentum is conserved. What about the energy? Do you think the initial energy is equal to the final energy? If F is equal to 0, we can put integral. If F is 0, Nandana, there is no impulse, because 0 into anything is just 0. Kishore, decent amount of time, depends on which chapter. Like for rotation, you might take a week, but if it is fluids, let's say statics, maybe 2-3 days. If it is solids, then maybe just 1 day. Okay, energy may not be conserved. So keep this in mind. Energy may or may not be conserved. Energy may or may not be conserved. You do not know that. Very, very important. Now, Once you understand that, okay, when momentum is conserved, when momentum is not conserved, etc., there are 3 different types of scenarios which you should know, and basically that is your types of collision. Types of collision, and there are 3 types of collision. Okay, one is called as elastic collision. The second one is just called as inelastic collision, and a more extreme version is basically perfectly inelastic collision. Perfectly inelastic collision. To understand that, we need a concept called as restitution. So let's see that restitution coefficient. This was given by Newton, and he said that this is a constant value. This E is a constant value for a given pair of 2 bodies which are colliding, and what you need to divide is the relative speed of separation upon relative speed of approach. Now many students remember the formula V2 minus V1 upon U2 minus U1 with the negative sign. Guys, if you are doing that, you are doing definitely a blunder. You will definitely get confused. I'll just give you an example. Imagine there are 2 masses, and this is the situation before and this is the situation afterwards. Let's say these masses are going with these speeds, let's say 2 meters per second, 3 meters per second. After the collision, let's say this goes with I don't know, 1 meter per second, this goes with, let's say, 4 meters per second. Example. Okay, everybody fine? Now, yes, Jaya, this is for JEE and NEET both. Think carefully, what should be there in the numerator and what should be there in the denominator? E will be equal to something by something. What should be there in the numerator first? Come on, put it up in the chat box. 1, 4, 2, 3. This is before, this is after. This is initially, this is afterwards, after the collision. Come on, put it up in the chat box. What do you think it should be? Relative speed of separation. They are separating. So you can see this and this, they are separating. That guy is moving faster than this guy. So what is their relative speed? 4 minus 1, isn't it? 4 minus 1. Yes, it is final by initial, but what is that final value? And initial, if you sit on this guy and look at that other guy, they both are coming closer. So their relative speed, you're going in opposite, so it will be 2 plus 3. So it will be basically 3 divided by 5 in this situation. Understood? Okay. No, it is not 2 minus 3, it is 2 plus 3, Lalitesh, because they are going in opposite. When you go in opposite directions, the speeds will add. When you go in the same directions, the speeds will subtract. PCMB, NEET 3, definitely PCMB will have the RRR series before your examinations. So that's how you're going to remember it. Now, for elastic collision, the value of E is 1. For inelastic collision, the value of E is less than 1 but more than 0. For perfectly inelastic, E is 0. That's what it is. And in this situation, when elastic collision is occurring, you will see that if you draw a graph of kinetic energy with respect to time, that graph will look something like this. It will come back to its original level. So the kinetic energy is maintained. You will see after the collision, it will get back its original energy. It will not be deformed. There is no loss of energy. But if you check this case, especially for inelastic collision, the kinetic energy with respect to time, that graph will look something like this. Initially, it will have some kinetic energy. It will collide, it will deform, etc. It will try to come back, but not so much. So you will see that there is a loss of energy. And that is lost in heat, light, sound, etc. So final energy is generally less than the initial energy. And in the perfectly inelastic case, if you draw the graph of kinetic energy with respect to time, you will notice that initial kinetic energy will go down and it will never come back, and you will see that this will be basically your max amount of loss of energy. Very, very important. Maximum energy is lost in this case. Is that clear? So these graphs are very important, give you an idea of how the collisions occur. Now many people also try and remember some weird formulas for collision between two objects, M1, M2 in terms of E. No need of doing that. There has never been a question where you need that formula. Even without the formula you can solve the questions. Okay, fair enough. Now there are some specific scenarios which I want you to know, especially for elastic collisions. For elastic collisions only. These are 4 important scenarios, and what are those scenarios? Observe. First scenario, if you have a mass colliding with another equal mass, let's say this has velocity, I don't know, u, this has velocity v, after the collision, you will see that if the masses are equal, then their velocities get exchanged, meaning this v will come over here and this u will come over here. Basically, exchange of velocities for equal masses only during elastic collision. 2 meters, 3 meters, that will become 3 and 2 inward. That's all. This is only for equal masses colliding with each other elastically. The second important property is if you have a teeny mass and if you have a very heavy mass and a teeny mass, and this mass collides with this mass with certain speed. This is before. Afterwards, you will notice that the teeny mass will just come back with the same speed in the opposite direction, and the bigger one still stays at rest. It won't be affected much, so it will still be at rest. So light mass colliding with a heavy mass at rest, that's what is going to happen. It makes sense also, right? Teeny thing colliding with it. Then the third one is when you have a very heavy mass moving with certain speed colliding with a very teeny mass. This is before. What you will see is after the collision, this mass will continue with the same speed, but the teeny one will move with double the velocity, 2u, twice the velocity. Thank you, Trilocha Satyakumar. The last property which you should know, the fourth one, is for oblique collisions or collisions at an angle. You will see that again, if you have two masses and they are equal, and this mass is at rest, very important, and this mass is projected with certain speed in this direction. After the collision, what you're going to see is this mass, when it collides with this mass, the mass with which it is colliding, that will go with certain velocity in certain direction, but this mass will get deflected and it will probably go here. Okay, it will go here. Okay, this was your original line, and this was your original line, and you will notice that the angle between these two is 90 degrees. So they move perpendicular to each other. Very important property. They move perpendicular to each other. Keep this in mind. Yes, I know about EMSAT. Maybe someday I will conduct a session, bacha. Yes, I will be doing questions as well. Okay. Last thing before we solve some questions. Yes, there are some questions ahead of this. So last thing before we go to questions. Basically, collisions in 2D or basically oblique collisions. One of the case of oblique or collisions in 2 dimension was this one. You will not see that the particles are going in the same line like in this or this. You will see they are moving in 2 different directions or 3 different directions. So in those cases, remember, you just have to conserve momentum in x, y, z separately. That is what you need to do. Most of the times you need to do this. Also, when you apply E formula, this is separation relatively, and this is approach relatively. Always measure it along the direction of collision only. What is the relative speed of approach and separation? Along the collision direction, meaning imagine there is a mass colliding with this mass, okay, and eventually they touch each other, let's say like this. This mass was going like this mass was going like this. So this velocity was here, this guy's velocity was here. These are two different velocities, u1 and u2. When you take relative speeds, do not just subtract or add u1 and u2. No. Always check along what line are they colliding. So when they hit, you will see that their impulse will be along this line. So this is called as the line of collision. And how do you know the line of collision? It is basically the common, it is nothing but the common normal. It is nothing but the common normal. You can see this is the common normal. So that is the line of collision. So only take the components of both the velocities. So only you will take the components of those velocities. Keep this in mind. Okay, so in my college, you are seeing that the time is getting wasted. Is it right to take holiday and prepare from home? Yes, definitely. Okay, all right. Last thing, there is one special formula for an object colliding with a surface. So let's say you have an inelastic surface E. This is my normal to it, and you see that there is a mass which hits over here and rebounds. It hits over here with angle of incidence I, and it rebounds like this with an angle of reflection as R. Then you will notice that tan of I, this is again using conservation and this principle, tan of I by tan of R is basically E. This is a very important formula, will help you in solving many questions. Okay, very important formula. Keep this in mind, especially for oblique collisions. Shall we now do some questions, my warriors? Let me know. I have taught you, I have revised all the major concepts which are there. And remember, I have also kept the mind map at the beginning. All these handwritten notes will be available to you after the session is over, right? So all these things are done out here. Okay, all these things are done. Ready, guys, for some questions? Let's start. First question coming up on your screen now. Trilochana, let me think, bacha. I cannot tell you right now, but I'll definitely let you know when I'm planning to take. Just stay tuned on the channel. Force displacement curve for a body is shown. The motion is in one dimension. The change in the kinetic energy in displacing the body from displacement 0 to 6 meters is how much? Okay, so the question is, like you can see, to find the change in kinetic energy. Change in kinetic energy is nothing but the work done, which is your work kinetic energy theorem, and work is nothing but area under force versus displacement. And what do we know? That whatever areas are on the top are going to be positive, like this one is 1 into 20, which is just 20. This is 1 into 10, which is just going to be 10. And whatever is there below is going to be negative, like this one. Minus 10 into 1, it's minus 10. This one over here, it's 1 into minus 20, so it's again going to be minus 20. So if you see the total area, guys, the total area is going to be 0. That's it, because equal and opposite. That's it. And the answer is 0. As simple as that. Work kinetic energy theorem, area under the curve, and there it is. Pavitra, next class will be tomorrow. I'm going to put up a important problem. Guys, do you know what is the dynamite series? So dynamite series is the series where I do one question, good question, above the mains level, and it will open up your brains. It's already there in our playlist. So one question, small, not small concept, small video, 10 minutes, 12 minutes, 14 minutes, around that time, and it will have multiple concepts. So I'm going to put up a video like that tomorrow. Day after tomorrow, there will be a special session, and then after that, I'll be doing a rotation. So after rotation, we are going to go to mock tests, because all the major chapters are done. Like you can see, current, electricity, capacitors, electrostatics, all right, magnetism, EMI, AC, all these things are done. And then we have also done kinematics, Newton's law, circular motion, work, power, energy, and next lecture, rotation also will be done. Cool? Rotation most likely Saturday, bacha. Okay. Work can, Abhishek, is charge scalar? Charge is scalar, right? But charge can be positive or negative both. So who said कि a scalar quantity can't be negative? It's just the sign of it. Sign does not mean direction. Direction is given by I cap, J cap, K cap, vector, bar, symbol. It should follow the laws of vector addition. So just because it is positive or negative does not mean it is a vector. It's just the sign of it. That's all. Keep this in mind. Okay, moving on to the next one. Shubham Samal, class 12th revision series will start very soon, but long-term series will not start. My long-term batch will start on the platform. My regular batch on the platform is going to be there. Okay, so please join that batch, but do not expect a long-term series, okay, in detail on YouTube. You will have problem solving, revision, one-shot strategies, those kind of sessions on the channel. Okay. Okay, so a body of mass this much kg is acted upon by a force which causes displacement. Now the question is, what is the work done by the force in 2 seconds? Let's do this. Avinash, thank you bacha so much for your contribution, means a lot. Thank you bacha so much, means a lot. Okay, oh, welcome Mukul, welcome back from the live session. Okay, the session will get over in half an hour, Pavitra. Okay, English syllabus, simple. I'm not sure what you mean by that. It's there. Just open the CBSE website. So X is given. Question is work done. Now usually work done, you can calculate if it is variable by integration of force with respect to displacement. But this force should be a function of X. The problem is I do not know the force as a function of X. So I don't think I can use this directly. But what if I do this? Work done by our theorem is also the change in kinetic energy, and change in kinetic energy is half m final velocity square minus half m initial velocity square. Maybe I can just find out the velocities and then solve the problem, because it is just half m final velocity minus initial velocity squares respectively. So let's find out the velocity. I think we can find that out. How do I find that out? Velocity will be dx by dt, and it is nothing but just the derivative of that guy, which is t square by 4. So t square's derivative is 2t, and divided by 4, which is nothing but t by 2. That's your velocity. So now think the work done in 2 seconds. What are you going to do? Initial velocity and final velocity. U will be, substitute t as 0. So it will be 0 by 2, which is 0 meters per second. Final velocity, put the value of time as 2 seconds, so 2 by 2, which is 1 meter per second. So this is what I got by putting t is equal to 0 and t is equal to 2 seconds. Initial and final. Now substitute it over here and see what do you get. The mass value is just given to be 6. Final velocity is 1 square. Initial velocity is 0. So it is just going to be 3 joules. Just check this out. Is 3 there? Option D. Yep, it is. It is option D, guys. Clear? Okay, fair enough. Let's move on to the next question. There is a rubber ball. Okay, Himanshu, I'll definitely try and probably discuss it towards the end, Himanshu. Is that fine, bacha? Okay. 2023 plus 2. Abhishek, 2023 plus 2 lectures are already there on the channel, bacha, and on the platform it will be already, the batch has started. My batches have already started, and a new batch will start probably in this next week. Just wait for the next week, it's going to start. Yes, Nangana, you can score 70%. You can score very good even with 70% of the syllabus. You can even get into NIT. Okay, fair enough. Thank you, Samyukta. Okay, so let's do the next one. A rubber ball is dropped from a height of this much meter on the surface of a planet where the acceleration due to gravity is not known. On bouncing, it rises to this much height. The coefficient of restitution is. Okay, let's try to understand. First of all, it drops from certain height. Okay, let's say the height is given to be 5 meters. So it will hit with some velocity, let's say u. After that, it bounces off, but not to so much of height. So let's say this is 1.8 meters and the velocity is just v. Now this is our surface. The question is, what is the value of the coefficient of restitution? In this situation, just remember the velocity and height are related by simple formula. And the formula, for velocity and height, you can use kinematic equations. So using kinematics, you will get velocity is nothing but root of 2 times of gravity multiplied by the height. This is the generic formula. So hence the value of u will be root of 2g into height, which is just 5. Same way, I can also find that v will be root of 2g into that height, which is 1.8. I have found this out using straight 1D motion kinematic equations, nothing else. V is root 2gh. Now, what is the value of E? E is always separation velocity upon approach velocity. Now, if you notice, this surface and the ball separates with a velocity of v. So it should be basically v divided by they approach each other with a velocity relative to each other of u. So this will just become this by this, v by u. So it will be nothing but root of 2g into 1.8 upon 2g, and you will have 5 over here. Root 2g goes. So 1.8 divided by 5. So that's nothing but 18 by 50. Correct? 18 by 10. So this will be nothing but 9 by 25, which is nothing but 3 by 5. That's the answer. And do I have it? Yep, it is. Option C. There you go. Fair enough. So concept of 1D motion along with restitution coefficient. Okay. Yes, Jacinta, you can definitely score well. That's the reason why I'm conducting sessions for JEE and NEET. Yeah, Rohan, definitely I'll make a session, but I'm just waiting for the maths exam to get over. The day maths exam is over, I'll be giving you a strategy session, because now many students are just probably into the board examinations. I'm so glad, Trilochana. Continue like this. Now use the Zero to Superhero series and the mock tests. Mock tests are starting immediately after your maths exam. 3 particles of masses this kg are placed such that one lies on the negative x-axis, second lies on the negative y-axis, third one lies on the positive z-axis. So we have 3 masses, mass 1, mass 2, mass 3. The masses are 2 kg each. This is also 2 kg, this is also 2 kg, and this is also 2 kg. And their positions are, first one is on the negative x-axis. So coordinate is 2 meters. So minus 2 meters, comma 0, comma 0. The second mass is on the negative y-axis at a distance of 3 meters. So minus 3 meters, comma 0. And the third one is on the positive z-axis. So 0, comma 0, comma at a distance of plus 1 meter. The question is the square of the distance of the center of mass. Okay, let's start by finding the center of mass. Each coordinate separately, obviously. So think about it. X center of mass will be m1 x1. So 2 into minus 2 plus m2 x2 plus m3 x3, 0, 0 upon m1 plus m2 plus m3. 2 plus 2 plus 2, which is 6. So this will become minus 4 by 6, which is minus 2 by 3. I'll keep it aside. Similarly, y coordinate of the center of mass will be 0 plus, or sorry, minus 3 into 2 plus 0. m1 y1 plus m2 y2 plus m3 y3. Two terms will be 0 upon 2 plus 2 plus 2, which is 6. So this will be minus 6 by 6, which is minus 1. Last thing, which is z coordinate of the center of mass, m1 z1 plus m2 z2 plus m3 z3. So 0 plus 0 plus 1 into 2 divided by 2 plus 2 plus 2, which is 6. So 2 divided by 6, which is 1 by 3. So I found out the coordinates. The only challenge now is the square of the distance from the origin. So the distance from the origin will be root of x square plus y square plus z square. X center of mass, y center of mass, z center of mass. That's it. Right? That's how the distance is calculated. X square plus y square plus z square is the distance. Just do the math, you will get the answer. So the answer will be, let's say, 2 by 3 whole square plus 1 square plus 1 by 3 whole square. So this will be nothing but root of whole thing divided by 9. LCM has been taken, 4 plus 9 plus 1. So this will be nothing but what is this? 10 plus 14, 14 by 9. But the question is the square of the distance. So the square of the distance from the origin will be 14 by 9. 14 by 9, that's 1.55, I guess. Hi MD, hi Dolly. Just check this out. Is it 1.55? Yeah, but units are important. Do not mark option C because this is meter. This is meter square. And the question is the square of the distance. Square of the distance should always be meter square. As simple as that. Okay, so many people will get confused and probably mark this. But yeah, C option is dimensionally only wrong. Fair enough. Let's move on to the next one. Rohan, yes, you can complete the remaining syllabus, but don't aim to complete 100% syllabus, Rohan. Try to complete whatever you do properly. If you have done 80%, that's a good amount. You can try to complete 90 to 95% syllabus, but try to do high weightage chapters and good topics first. Hi Shri Krishnan, welcome back, long time. A man of 80 kg is riding on a small cart of 40 kg which is rolling on a level floor at a speed of 2 meters per second. So there is a cart, and what is the mass of the cart? The mass of the cart is 40 kg. This is the mass of the cart, which is 40 kg. And this cart is moving with a speed of 2 meters per second. So it's moving like this, 2 meters per second. And there is a guy on it, there's a person on it, and that person has a mass of 80 kg, you can assume it to be Pandu, and he moves with a relative velocity of 3 meters per second to the cart. Relative to the cart, his velocity is 3. What do you think his actual velocity with respect to ground is? Come on, let's see. Hi Mohammed, hi Cutie Gugu. Cart will move 2 meters in 1 second. The person will move 1, 2, 3 meters opposite in 1 second. Cart moves 2, the person moves 3. So actually he has moved 1 behind. Yep. So 1 meters per second is with respect to ground. With respect to ground. I have found this out using this. Think of it this way. The cart has moved 2 meters in 1 second. That Pandu has moved 3 meters in 1 second. So effectively he has moved 1 meter in 1 second. That's how I got it. Now the last part is finding the velocity of center of mass. So velocity of center of mass is m1 v1 plus m2 v2 upon m1 plus m2. What is m1? m1 is 40, let's say. So 40 into 2 upon m1 plus m2, that will be 40 plus 80 plus m2 v2. m2 is 80. m2 is 80. v2 is just 1 but with a negative sign. It's a vector quantity, keep this in mind. These are all vectors, so put signs. If you do that mistake, you'll get a wrong answer. 80 minus 80 is 0. So the answer will be 0 meters per second. That means the center of mass is not moving, it is at rest. That's option D, of course. A lot of students put it as plus, so 80 plus 80, 160 divided by 120, they do all those kinds of nonsense. No, that is not the correct answer. Got it, guys? Keep this in mind. Moving on to the next one. Very good IIT aspirant, excellent, you got it. Let's try this out. Next one. The position of two particles are given by this and this. The velocity of the center of mass at 2 seconds is 2 meters per second. What do you think is the velocity of the center of mass at 4 seconds? Interesting. So first, my aim will be to figure out what is the velocity of 1. Velocity of 1 will be dx1 by dt. So if you take the derivative of this guy, derivative of 2t is just 2. Similarly, x2 is given. So velocity 2 will be dx2 by dt. So therefore, velocity 2 will be 2's derivative is 0. 3t's derivative will be 3. Oh, what did I get? Both these velocities are not a function of time. There is no t in the answer. That means v1 and v2 are constant. They are constant. And if v1 and v2 are constant, what does it mean? Center of mass, Vc formula, which is m1 v1 plus m2 v2 upon m1 plus m2. If this does not change, this does not change, how will this change? So hence, velocity of center of mass is also going to be constant. And do I know its value? Yep, it is 2 meters per second. So it will always remain as 2 meters per second, no matter when you measure it, be it 4 seconds, 100 seconds, 0 seconds. Hence the option is A. It's constant. No, the acceleration is not asked, velocity is asked at aspirant. Be careful. Brilliant question. Cool. Let's move on to the next one. There are two blocks. There are two blocks of masses m1 and m2. They are connected with an ideal spring kept on a frictionless plane at rest. Another block of mass m3 making elastic head-on collision with the block of mass m1. After the collision, the center of mass of m1 plus m2 as a system will be. Okay, so once they collide, the center of mass of m1 plus m2 will be making elastic head-on collision. So what will happen? This mass m1, okay, this m1 will get some velocity. This spring is there. This m2 will be at rest as of now, and after that you will see the spring will get compressed and even that mass will start moving. Now in this process, when this mass hits this mass, transfers its momentum, and then the spring starts compressing, and then this mass starts moving, this mass also will move in a different manner because the spring will start compressing, etc. You will notice that after the collision is done, this system is in a way isolated system. Isolated system. The spring force is basically an internal force. So it's an isolated system. Collision is done. Isolated means the external force is 0. Hence the momentum is conserved. That means the center of mass moves with constant velocity. So the center of mass will move with constant velocity because there is no external force. Keep this in mind that only an external force can cause the acceleration of a center of mass. External force can cause the velocity of the center of mass to change. Here external force is 0, center of mass will not accelerate, it will move with constant velocity. Hence that's the answer, move with uniform velocity. Option B it is. Next question. Yes, Govind Mittal, I do take the 12th standard batch. I'll be starting the 11th standard batch. I'm also taking the crash course. You name it, my batches are there. But if you're already a pro student, you will be already in the live classes. So make sure you continue in the batch. Don't come to my batch SAE because you are already ahead in schedule. So continue with your batch. Have faith. You can always check me out on YouTube. Okay. Let's move on to the next one. Here, there is a billiard player hits a stationary ball with an identical ball to pocket the target in a corner pocket that is at an angle of 35 degrees with respect to the direction of the motion of the first ball, assuming that the collision as elastic collision, that friction rotation is not there, the deflection of the incoming ball is. I think there is no other way other than drawing the diagram. Salman, just repeat that by going behind. Even in a live class, you can move the slider and you can watch the same thing again. Okay, so I'll just move on to the next question. I'm pretty sure you can watch the replay or just move the slider back. So let's try to draw it. Hits a stationary ball with an identical ball. So this is my stationary ball. This is my stationary ball. By an identical ball to pocket the target ball in a corner pocket that is at an angle of 35 degrees with respect to the direction of the motion of the first ball. Okay, so let's see. This is my incoming ball. So this is my incoming ball. So this is my incoming ball, and this is thrown. This is being pushed, hits a stationary ball, and it will hit another ball. Okay, so let's try to do this. It's going to hit over here, and I think I just gave you one rule over here just some time back. See, where did it go? Two balls, one of them is moving, one of them is at rest. After the collision, they move perpendicular to each other. Do you know that? Yeah. So let's try to do this now. Okay, so here we come. Okay, now this is the incoming ball. He hits the stationary ball by an identical ball to the pocket. Okay, fair enough. Now what happens is after the collision, what you will see is this ball will go like this, and this ball will start its motion and it will go like this, and this whole thing is 90 degrees. Now it is given that it makes an angle of 35 degrees with respect to initial direction of motion. There is a pocket over here. And this ball goes inside the pocket, and it is mentioned that that the initial direction of the first ball is making 35 degrees with the initial direction of the motion. The pocket here makes 35 degrees. So the question is, what is the deflection of the incoming ball? So the question is, what is this angle? This is 35 degrees. How much is this? Come on guys, how much will it be? So there is this incoming ball, hits, gets deflected, this ball goes here, this is 35, total is 90. Come on guys, it is obviously going to be 55 degrees. That's the answer. As simple as that. Okay, Kondeti Parasana Flash series was a series conducted last year. That is not a long-term series. That is not a one-shot series. It's somewhere in between. It's like a fast-track series. If you want to complete a chapter in a fast manner, but not one shot. So that is your Flash series. An explosion blows a rock into 3 parts. 2 parts go right angle to each other. These two are 1 kg first part moving with this much speed, 2 kg second part moving with another speed, third part this much speed. What is its mass? Draw the diagram always. So there is an explosion blows a rock. So there was a rock and 3 parts are going to come. So this was at rest. So the first part, that's 1 kg and moves with the speed of 12 meters per second. So it is 1 kg and it moves at 12 meters per second. 2 kg moves with 8 meters per second. 2 kg moves at 8 meters per second. And it is clearly mentioned that they are at right angles to each other. Right angles to each other. So obviously there is a third mass now. There is a third mass, and the Mass is not known, but I just know one thing. This is unknown. This velocity is 4 meters per second, and it will be exactly opposite to, wherever these masses are going. So that the total momentum is always conserved. So keep this in mind in this problem. The net momentum is basically conserved. Is conserved and is 0 always. And is going to be 0. So can I say, if initially it was at rest, finally also total momentum should be 0. Hence, can I say that the momentum of M numerically will be equal to the momentum of 1 and 2 kg mass, but direction wise they will be opposite. If one is this way, the other one will be exactly the opposite way, so that what will happen, guys? They will end up cancelling out each other. Equal magnitude but opposite in direction. Equal magnitude but opposite in direction, so that their total vector sum will be 0. Everybody understands this? Very good. Let's try to solve this now. So what is the momentum of 1 and 2 together? That is a vector quantity. So the momentum of 1 and 2 together will be, 1 and 2 together will be this square plus this square under the root using Pythagoras. P1 square plus P2 square, which is nothing but root of 1 into 12 mv, mass into velocity is momentum, square, plus 2 into 8 square, which is 144 plus 256, because 8 2s are 16, 16 square is 256. That's going to be root of 400, which is nothing but 20. Wait a minute. So this is this and this is this. Hence, what did I get? I got the momentum of M, which is nothing but M into 4. M into 4. So M into 4 is 20. Hence, M will be 20 by 4, which is just going to be 5 kg. And is 5 kg there somewhere? Yes, it is there, Anisha. Very good, IIT aspirant. Excellent, my warriors. Option D it is. So the concept used here was oblique collisions in 2D or explosions in 2D. Total momentum was conserved. So I know that these two masses, if they are going this way, third mass should go somewhere like this. Their total momentum should cancel. So momentum of this guy will be the total momentum of this guy numerically, direction wise opposite. So this guy's momentum, since they are perpendicular, use Pythagoras, P1 square plus P2 square. And this guy's momentum is mass into velocity. Mass I do not know, I found it out. Next question, let's try to do this. There is a trolley containing water. It has total mass of 4000 kg and is moving at speed of 40. Now the water starts coming out of a hole at the bottom of the trolley at the rate of 8 kgs per second. The speed of the trolley after 50 seconds is. I feel this is also a question on momentum conservation. I'll tell you how. This is at t is equal to 0, or I would say this is initial condition. This is before, and I had told you whenever you apply momentum conservation, you always show before and after diagrams, just like it over here. Before, after, before, after. Always show the two diagrams. Without the two diagrams, you will not be able to realize what's happening. After some time, you will see that a trolley has come over here. Okay, this is the trolley. Now, this is at t is equal to how much? 50 seconds. Okay, this is obviously afterwards. Now, if the mass is coming out at 8 kgs per second, how much water would have spilt out? Think about it. How much water would have spilled out? How much water will spill just outside? Think about it. 8 kg is falling per second into 50 seconds, which is just going to make it 8 5 are 40. So 400 kg. 400 kg of water will just spill outside, and that will be at rest. It will just spill and it will fall. It's just falling on the ground. That's all. Harmonica, thank you for the blue heart. Now, what will be the mass remaining? Come on, put it up in the chat box. How much mass will be remaining? If out of 4,000, 400 fell out or it spilled out, 4,000 minus 400, that's going to be 3,600 kg will remain in it. This will now have some new velocity which I do not know. Now the momentum before and after should remain conserved. So let's use conserving momentum. Conserving momentum. Let's see what do we get. The final momentum should be equal to initial momentum. What is the final momentum? Mass into velocity. This water has no momentum. Mass is 3600 into V. The spilt water is at rest. So 0 is equal to the initial momentum. Oh, sorry guys. My bad. The whole thing, I drew it going this side, but actually it's going the other side. So my bad. I forgot to see that the arrow mark was that way. So I'll just put the arrow mark this way. This is this way. Ignore that arrow mark otherwise. Okay. So what is the initial momentum? It's everything inside. The total mass is 4,000 into what's the speed? It's 40, of course. So these two zeros go away. So the velocity value 40 into 40, that's 1600 divided by 36, of course. So 16 goes with 36 4 times, so 4 and this will be 9. So 4 by 9, just check this out. I think it's going to be 0.444 because 9 4s are 36, 4 remains. 9 4s are 36, so 0.4444 recurring into 100, which is just 44.4444. That's the answer. Just check this out. Do we have it? Yep, it is option A. Option A. Very good, Dayanand. Very good IIT aspirant. Hi, Nakshatra. Welcome aboard. Let's move on to the next one. Okay, so what do we have? A machine gun which fires a bullet of mass 40 grams with this much speed. The man holding can exert a maximum force of this much on the gun. How many bullets do you think he can fire per second? Hi, Sanchana. Nice to see you back from yesterday. Well, whenever you are firing some number of bullets per second, that force which is acting on that gun will be given by the total change in momentum upon the time taken. Now the total change in the momentum is the number of bullets that you shoot into the change in momentum of any one bullet. So each bullet, the momentum will change because it was at rest, you're hitting it, so it moves. So there are n bullets, so n into change of each one will give you the total one. So this divided by delta t. Now this by this is nothing but number of bullets per unit time, this is what it is, and into change in momentum of any one bullet, that's going to be final minus initial momentum. Final will be mass into velocity. Initially it was obviously at rest. That's it. That's how it comes out to be. The force is number of bullets per unit time into mass into velocity. Now just do the math. The force is given to be 144. The number of bullets per second, I do not know. So number per unit time, I do not know. Into mass is 40 grams, so 40 into 10 to the power minus 3. Into velocity, that's 1200. So this will become n by t, and 12 fours are 48. Here you will have 10 to the power 3 and 10 to the power minus 3. These two will just cancel. Okay, bring it over here. So this is 144. So 144 divided by 48 is number of bullets per unit time. This goes with 12 4 times. This goes with 12 12 times. 4 goes with 12 3 times. So n by t is basically 3. So 3 bullets per second should be the answer. Just check this out. Yeah, it is. Perfecto. Excellente. Many of you have answered it. Excellente, Sonalika, Anisha, Dayanand, Apple NEET aspirant. Very good. Okay. Here is the last question, I guess. A lead ball strikes a lead ball, sorry, strikes a wall and falls down. So you have a lead ball strikes a wall and falls from here. This is case 1. The second case, a tennis ball also strikes the wall, but it bounces back. Which of the following is correct? Which of them has more change in momentum? Okay, now if you see the first case, see, it falls, that means it starts from rest over here. It falls, that means it hits, loses everything and falls. So the change in momentum here, which is final minus initial, final is 0, initial is mv. So if you talk about the magnitude of the change in momentum, it is just m into v in the first case. In the second case, if you notice, the change in the momentum will be again final minus initial. Final will be minus mv. Initial will also be just mv. Directions are opposite. This side is positive, this side is negative. Right positive, left negative. So it will just become minus 2 mv. So the magnitude in this case will be 2 times of mass into velocity. Obviously mv is small, 2 mv is more. So the momentum change in the tennis ball is definitely more. So the tennis ball suffers a greater change in the momentum as compared to the lead ball. Done. Option B it is. No quantity, you cannot. No, never. That is dangerous, injurious to your performance. Now, like every time, there is a small assignment at the end. It's there in the description box. Make sure you solve it. It's in a timed manner. You will get to know how much you're scoring, in that stipulated time. Not just that, there are also links for joining the crash course for NEET as well as JEE. This crash course will help you build confidence, solve a lot of problems, and you will also get the recordings which are interactive till the last day of the exam, not 3rd July, till whatever is the advanced exam. Same thing with NEET as well. You will get PCB in NEET, in JEE you will get PCM. You will also get in the class support via hotspots, via quizzes, via personal feedback. Also with the help of the class teacher, you can see how you are performing and where you are going, and if you do not know anything, you can ask the class teacher. 2 teachers in 1 class. There is also this test series which you will get, and you will also get lots and lots of assignment for all the chapters of JEE and NEET. So it looks something like this. So if you are in the assignment, this is how the assignment looks like. See, so many questions will be there. You can go to any question and you want to solve it. Fair enough. So let's say, what is pneumato force or characteristic feature of, I don't know. I like this name. I'm just going to click it and just say check. Oh my God, what a fluke. It came out to be correct. View solution. You took so many seconds. There you go. Same way, you also get to know how is your performance in the test. This is a dummy score. Don't get scared. Okay. So how was your accuracy? How many attempted and not attempted? Time taken per question, etc. Rank, your predicted rank, time taken wise analysis, overall analysis, chapter wise analysis, all these detailed report cards, difficulty wise analysis, question type wise analysis, all these things you get. Okay, this is all there as a part of this crash course. So I am teaching you guys physics in the JEE crash course. I think many of you know that. The best part, it is just for 2,700. Don't worry, even if it has started on 9th May, you should use only the recordings, because now is not the time for watching a live class. Watch only those parts which are needed. So, okay, rotational motion, only this part I need. Watch it, start solving assignment. You do not get something, again watch the recording. That's how you're going to use it. PDF notes are going to be there. Make use of the mock test. I want you to do all the 20 mock tests which are there. Remember, there are not many days before your NEET or JEE exam. If you start even one day, one mock test, it's going to take you 20 days. Okay, so guys, buckle up, start preparing and make the best use of the crash course resource which is there for you. 2,700 is not a lot, considering the fact that you can get a very good rank, you can get into a dream college, your dream NIT, your dream IIT, your aspirations can be fulfilled, and that way you will save a lot of money, where you would otherwise spend in a private college. Lakhs of rupees you can save. Thank you very much, guys. Thank you, Nikita. Bye bye. Take care. Sonalika, Nandana, IT aspirant, Apple, NEET aspirant, RJ Beats. Bye bye, Anisha. Have a great time, Joyce, Sanchana, G Praveen. Make sure you stay safe, stay well. And tomorrow, Dynamite series, one question, JEE Mains Plus level, which will help you understand many concepts in just a short span of time with multiple concepts. And day after tomorrow, a special session for everyone. And after that, rigid body mechanics. That's most likely on Saturday. And after that, only mock tests every day till your JEE and NEET exams. And if any special sessions or special topics are required, I will do it from time to time. Bye bye. Have a great time. Have your dinner and stay safe, guys. Hasta la vista. Captain Shreyas signing off.